Ladies and gentlemen, my name is Ingus and I'm from IGS Electronics, and today we are going to be progressing with our Mitsubishi training. And what we got on agenda today is MOV, one of the widely used functions in PLCs. So that is something we definitely want to get our head around. So what MOV is, basically is quite straightforward. The contents of the transfer source S, basically a source, are transferred to the transfer destination D. Quite straightforward. There's a couple of examples Mitsubishi has played out. A lot of these in here is quite straightforward. It's quite easy to understand. We're going to go through quite a bit more about this first one. What is this? This is K1 X00 and K1 Y00. That is something very interesting and very useful move for instructions. So that is something we're going to be checking out properly. So without further ado, let's get to it. I have created a program already for our trialing, so you guys don't get bored for me watching me writing a program up. So what you can see in here, and the first thing we're going to get is this guy in here. What does this mean? Move K1, M0 and K1 and Y0. If you get back quickly to the manual, as you could say in here, it's going to sort of give you a conversation. When a constant K is specified as a transfer source, it is automatically converted into binary. And then it says that the bit device transfers a maximum of 16 points for the word, for the 16-bit system, and it goes in multiples of 4. So what does that mean? So let's have a look at it. So if we are, because as soon as you put K in here in front of M0, that is becoming a binary system. Alright, binary code in there now. And that binary numbers, the binary data will be received from these M0 all the way to M3. Remember, it says in groups of 4. So K1 will represent M0 to M3. Y in here, as you can see, K1, Y will represent Y0 to Y3. So that's the only thing that's going to be working in this move instruction, and the execution is going to happen accordingly. Let's say you have a Y0 occupied somewhere, Y2 or whatever. This will start working, so make sure that is wise. The output sources, or not sources, but output bits are not occupied anywhere in the program. Otherwise, this will cease to work, and basically you will have problems. So let me show you how that works. The key in here to understand this properly is understand the binary system. So how the binary works is if you look at all the bits itself, it's a bit 1, 2, 3, 4, 5, 6, 7, 8, and go on. But in binary system is 1. The bit 0 is going to be as classed as 1. Bit 1 is going to be classed as 2. Bit 3 is going to be classed as 4. Bit 4. Now bit 3 is going to be classed as 8, and so on. So pretty much do check up online if you do want to understand a bit more of it. But if you can see in here, what we're going to do, we're going to start modifying the values. So as you can see, I put M0 on. So he knows that he needs to read data from this as these inputs or whatever they would be come on. So he reads that my M0 came on. I know in my group that is 1. So let's turn it off. So now the M1 comes up. He knows that is a second in his bit system. So he knows that's the value 2. Okay. So and then the third one obviously is going to be our 4, because that's a third bit, and no, that's the third bit, and our fourth bit is going to be on, and as you can see, that represents a value of 8. I know it's bit. Get your head around those bits, but like I said, it's just the numbers. Next, let's have a look a little bit more how that looks in the PLC. So here we go. We got the PLC. So by turning these things on, as you can see down there, let's turn this guy on. So bit the input 0 and input 3. As you can see, that is a value of 9. So, and then obviously that is going to be basically all it does is just represents a value, and that value can be transferred into the Y, and those all the Y's will come on, and you can manipulate this value whichever way you want. This is like a sort of a way of showing with the M's, but I'll quickly show you how that can be really useful into some other ways of doing it. As you can see, they're all 4 coming on. That will represent a value of a 15. So let's see what happens. Let's turn this off. Let's turn this off. So now we're going to stop playing with this, and we're not going to be switching these on. We are going to go into a watch. Register to watch. As you can see, we can modify the K1 M0. So let's change that one to 16. As you can see, nothing happens, because we have said that the last bit is M3 and last output is Y3. And for the Y4 to come on, that would be a bit combination of 16. The value of 16, that will be the 4, and that will be the second group, because remember, we're working in 4s, so multiples of 4. So now we have to tell PLC we want to continue. Oh, my camera's jumping around. I do apologize for that. We need to continue. Tell the PLC you can read past that input 3 or Y3. So to do that, you need to up your K value. Let's get this up. So remember, as you change this, let's say change this to a 2. And we change that one to 2 as well. Now it will work. It will be occupying Y0 all the way to Y7. And then it's going to be for M's. Yeah, it will be occupying M0 all the way to M7. Of course, we're not going to be doing that. So, because that's just demonstration purposes. So let's load this into PLC and see what happens. There you go. Come on. So now we've done that, so let's see what happens. As you can see down here, I have created a little bit down here for something different, which you can show in a minute. This is where it becomes really cool. So let's go into monitor mode, and now let's try to edit value to 16. Not 126, it's a 16. And we need to change that one to register to watch. So we need to watch this one now. 16. Look what happens. Here we go. So now if you stick into PLC, the output 4 has come on, and that is represented by a value 16. And let's change that to 32. And as you can see, output 5 comes out, and I'm hoping you guys are starting to get the gist where you can possibly really use this. Now let's have a look at where could this become quite useful, and how I would personally use it. I wouldn't use these systems in here. Let's just delete that off, and I will change that so I no longer need incoming bits, so it doesn't need to count a value from the values anymore. So I'm going to change that to D. So data register D, let's say 20. So what do we? Oh, we are not in a right. Oh, we are in a. So D20. There we go. So, and as you can see down here, I have move in here. K7 to D20. So let's see what happens once we load that in our PLC. This is where you can turn large things on and off in whichever combination you wish by just transferring a digital number, well, a number into it, so which would represent those inputs. Oh, sorry, those outputs. So let's go in monitor mode, and so now I say I want, what does that work out? 1, 3, and a 4. That will be 7. 7 will give me outputs 1, 0, 1, and 2 to come on at the same time. So on. There we go. As you can see, by just transferring a value into D20, I was able to manipulate outputs in this manner, this way. And this way you can, by just sending numbers, you can manipulate the value. Let's have a look how to do that. Let's put this into a watch. So we're going to be manipulating this guy. So let's change that one to 55. Did we K7? Did we have changed that? Why didn't you? That's a single word. Why didn't you? 44. Why are you not happy? Oh, because sorry. Yeah. There we go. Because this guy is on. We need to. So yeah, do make sure that those things are off. So because it keeps sending this 7 into D20, keep overriding me. So now let's change that to 55. As you can see, the output 0, 1, 2, a 4, and a 5 came on. Let's go. Oh, my camera is doing this flipping again. So let's say go for the maximum 255. As you can see, all outputs come on. And then let's say value of 67. I hope you get the gist what you can do with this. It's some cool stuff with that. This really could narrow down your program to very a lot shorter than you normally would do. So that's regarding these kind of move instructions. So let's get there. And the next one is, I guess, quite straightforward. Is basically moving value from D1 to D2. I can actually take the D20 to put it in here, and that'll be moved in there, and basically move the values around from one D to another. You also can move, as you can see there, move a K constant value, which you already did down there, and you can move it into D10, and that D10, where are we? It's going to be, I can show that in a minute. First, let's understand how the data registers work. In a single word, register to watch. In a single word, you have 32,700. I don't know. Is that the right one? So that would be, I think, 730, something like that. So that is the maximum into plus, and you can do the same in a minus. So basically, it adds up to 65,000 something. So this is the maximum for the word. As you can see, the managed value. Again, these data registers, as you've probably seen in some of my analog card videos, this is how these data registers are working. And these can be used all sorts of different ways, representing all sorts of different things. But if you, by any chance, need more, and those chances are going to be a lot, because especially if you use the encoders, the high-speed counting, and things like that, you'd go to double word. From the double word, let's see what happens if you move that K1 in there. So do that. As you can see, the value popped up as 65,000 because it will as soon as you put DMOV, it will continue where it left from 32,000. Next one up is 65,000. From there on, it carries on to millions. So let's change that one. Let's see if you register to watch that one as well. Yes, I know the bit is on. Well, that's quite nice to display that. Off. There you go. So where are we? D10. D10 didn't even pop up in here. D10. Why you don't know? Come, here we go. Here we are. So if you change that one to 2, as you can see, it comes to 131,000, and hopefully you're getting the gist. It's just it keeps going to 32-bit system. So what else you can do? You could use data registers as well to manipulate the timer values and counter values. Let's have a look how that works. As you can see in here, I am where are we? So D, as you can see, the timer 0. It is instead of a K constant value, we have a D value, which is being read from this guy. And here, where is receiving a move instruction to move a K5 into the data register 0. So let's have a look how that works. So as you can see, 5 is going in there. So and we turn a timer on. As you can see, it stops at 5. So that's how you can manipulate the timer values there, and also that happens as well for the counter as well. As you can see, D3, it will be reading the counting value from the data register 3, where it is moved, where the 50 is moved in there. So that, ladies and gentlemen, it is MOV function, instruction, whichever way some people call it. Hopefully it's giving you a good understanding. I think this part in here is really cool. I think it could potentially narrows down the programming time quite significantly. So I hope this is helping you out in every possible way and giving you good ideas for your next program. And other than that, ladies and gentlemen, that will do with MOV, and we will be moving on to shift move in the next video. So we can be checking that out. So if you like that video, please smash that like. If you didn't, smash the dislike. Comment below any questions and things like that. Do ask, and I will answer them as soon as accurate as I can. Other than that, thank you very much for watching, and I'll see you in the next video.